like everyone's here, so we're going to get started. Hello again, and welcome to the Multicopter webinar series. There's just going to be a few items to go over before we begin. Everyone in the audience will be muted. If you have any questions, please write them in the question queue or the chat, and we'll be sure to answer them during the Q&A portion at the end. Today's webinar is an overview on LiDAR scanning for construction sites, project accuracy and efficiency. So without further ado, please welcome our enterprise sales specialist for survey mapping and public safety, Dan McGreevy, and special guest, Will Rassid, regional sales manager at Phoenix LiDAR. Take it away, guys.
Thanks, Alex. Good afternoon, everyone. My name is Dan McGreevy. I'm with Multicopter Warehouse. I'm based here in Austin, Texas, and I am an enterprise sales consultant. Quick little blurb about me. I have an aviation background for about 20 years. I worked in software capacities in private aviation, aircraft sales, and also operations roles at airports around the country. I have 4 years of commercial construction project management experience. I'm an active licensed 107 pilot. I have flown commercially in the mining industry and landfills. I did about a year of working in the field, flying all over the country. But yeah, let's go ahead and get started. If you aren't familiar with Multicopter Warehouse, basically we are a dealer of multiple drones and payloads, serving, mapping, surveying, law enforcement, and more. We pretty much provide not only the equipment, but the training, the support, and service to make sure that you guys have a good user experience in the industry. Today's agenda, we're going to just go over briefly an introduction to LiDAR, if you're not familiar with LiDAR, and go over some of the advantages of it versus traditional survey methods. The process of data collection and some best practices, and then take you through into the kind of the processing and the software side of it. I have a special guest, Will Rassid with Phoenix LiDAR, who's here, and he's going to kind of take you through their process. If you don't already know, LiDAR is light detection and ranging. It's a remote sensing technology that employs pulsed laser light to measure distances. In a LiDAR system, laser pulses are emitted towards a target, and the reflected light is captured by a sensor. By measuring the time required for the light pulse to travel to the target and return, the system can ascertain the distance to that point. By rapidly scanning the environment with these laser pulses, LiDAR generates a highly detailed point cloud representation of the target area. So kind of jumping into it, just some basic information as far as field gear and equipment. Obviously you need a drone with a capable payload for a LiDAR. I have a picture of the IF-800 here, the inspired flight. Below that's the recon payload, what we're talking about, what that Phoenix has. And typically a base station may be needed for the work. Ground targets and software and hardware, there's a lot of choices, a lot of options. We won't get too specific on all that today, but just wanted to kind of give you a high level of some of the gear that's required. As far as construction, some of the values that I've seen, and we do have construction companies using LiDAR daily, is to document site progress as far as having historical data of a site. Having these historical records bring a lot of value, for future use, for looking back on jobs. It's a great tool for measuring takeoffs for estimators and trades. When you're doing your pre-construction layout work, and on down through the whole life cycle of a job. There are some advantages with environmental compliance as far as watershed, vegetation, and even code enforcement. Having a bird's eye view of your site can bring a lot of value add for your clients, your customers, and for your own internal resources. And typically, those would be pushed into as-built or future deliverables. So it's really, in some ways, you can almost see it as like an insurance policy on a job, and can open up a lot of new opportunities. Usually the first thing people ask is, they're curious on the costs. I mean, LiDAR, taking on LiDAR if you don't have drones yet, you're not using drones, there's going to be, obviously time, research, the effort to learn the stuff and actually put it to work in the field. and the money. And then there's going to be software and really the ability to master your process. Everybody uses these tools differently in different ways and wants different deliverables and results. Typical LiDAR payload for a drone can range from $12,000 up to $150,000. If you were to outsource LiDAR services, I've done a little research. It sounds like, if you were to hire someone in your area to come out and fly a site, it could be anywhere from $6,500 to $9,000 per day, and get up to as much as 12,000, depending on, the deliverables and what you need from that provider. Software licensing is also very custom. Will, who's here with us, will kind of get into a little bit about what they offer with their software platform, but that should definitely be put into your budget. And I put in 5 to 10K range. That may be an annual cost. Really just kind of depends how you want to structure your arrangement and what software you need to piece together. Same thing with your equipment in the office. Obviously we're working out in the field. If you are processing in the field or even at the office, usually most folks that are in photogrammetry and LiDAR have a pretty decent laptop or computer that can at least handle processing large amounts of data, be it photos and data files and whatnot. Real quick, some of the advantages of LiDAR versus your traditional survey methods. It is really a tool for efficiency, right? Time is money. Traditional surveying uses manual processes and manual tools. It increases time, money, and manpower. LiDAR is better for covering large areas quickly, while traditional surveying is maybe better for smaller spaces. And obviously, because you're in a drone and you're in the air, you're not having to, traipse all over all kinds of different places that we go in that life. So yeah, LiDAR captures comprehensive data, including topography and canopy layers, and we'll show you some examples of that. It is actually environmentally friendly in a sense from more of like an operational perspective. I mean, having multiple crews go out on a site and spend, with LiDAR, what could maybe be done in a couple hours might require a couple days. I have a client here in town in Austin that we just did a 25-acre site. The actual flight time of the drone was about 25 minutes, and we were out there for about 2 hours, and we were done. And he had told me that with 2 crews, which I think is about 6 guys, it would have probably taken about a day and a half. So that was just kind of a throwing something out there for you. But on top of kind of the efficiency and the value adds of using LiDAR technology with drones, the collaboration that can come about with traditional survey methods and LiDAR together with traditional surveys can actually lead to some new innovative approaches in mapping and surveying. So there's a lot of other aspects to incorporating this technology that can really change the way you guys do things. I already kind of said this, but they're capable of accessing remote or hazardous areas safely, such as dense forests or construction sites. Likewise, LiDAR can be used in the dark. Photogrammetry is kind of at the mercy of the elements in some ways. We'll talk about that in a minute. But the goal here too is that LiDAR is not it's not intended, it should never be replacing a surveyor. It's enabling you guys more visibility, efficiency, and optimization within your scope of work. As far as disadvantages of LiDAR versus traditional survey methods, like I said earlier, LiDAR scanning systems are going to require you to do research and setup and training and calibration and really get familiar with the technology, which we will talk about how that works. If you have questions at the end too, we're happy to answer those. Weather can impact LiDAR, heavy rain or fog, high winds. That's going to be the case with drones all around anyway. The initial costs up front are usually higher due to the purchase and maintenance of the advanced equipment. And LiDAR, due to the price tag and the investment, I mean, Drone pilots, there's a lot of licensed pilots out there, but you're probably going to want to hire someone that can handle the responsibility of flying, a $50,000 to $100,000 asset, and not have accidents. And so you definitely want to make sure you have experienced people lined up. Software, I already brought this up. The licensing can definitely be a cost that can add up. And then processing the data can require training and hardware resources. So sometimes actually when the flight is ready to go and you launch the drone, that's probably the easiest part of it in some ways, because it's a lot of the post processing and the pre-planning and whatnot. And obviously, crashing a LiDAR drone is a very expensive endeavor, and that's what the insurance is for. We recommend that you get insurance if you don't already have it. That being said, I want to introduce Will. This is Will's with Phoenix, and this is actually a photo of us. We actually just flew at the Commercial UAV Expo and did a demo in front of a live audience in Henderson, Nevada. And we flew a park with the Recon XT payload, and presented the data to the audience. And if you want to see any samples or data, let us know. Just send us a message in the chat. We're happy to provide you guys with some more in-depth collateral on some of the stuff. So with that, I'll let Will take it away.
Yeah, thank you, Dan. Thanks everyone for joining us today. Just a quick little background on myself. My degree is in civil engineering. I worked in the field flying Phoenix systems as a Phoenix customer for about 6 years, doing all sorts of different LiDAR projects coast to coast. But I also did photogrammetry. I did asset inspection. I was generally the go-to drone guy within my company. And with that, was able to gain a lot of experience with these systems. In total, I've got over 500 hours of flight time. And when eventually I decided to take a step back from being in the field, looking for a new opportunity, joined Phoenix because I knew the team, knew the product, and believed in it, and was able to take that experience and use that to help our customers be set up for success. Dan touched on it briefly, but if you're looking at LiDAR, no doubt you're looking at photogrammetry as well. Maybe you're using it. I wanted to go into a couple of details of how these two technologies vary. At the high level, photogrammetry is a passive sensor. LiDAR is an active sensor. What does that mean? With photogrammetry being a passive sensor, you have a camera sensor that's receiving the light that's reflected from the sun off of the surface of objects. With LiDAR, you're broadcasting your own photons down. Those little particles of light are being shot out by the system, going down and hitting the objects on the ground. And that's why Dan mentioned LiDAR, you can operate at night. Photogrammetry, you're very much limited by sun conditions. A partly cloudy day is kind of your worst enemy when it comes to photogrammetry, because you get shadows, you get bright lights, bright sun versus LiDAR. I've collected projects at 2 a.m. and pitch black in the middle of winter. In practice, I wanted to show you an example here. This was a project that I had done where we had scanned the site with both LiDAR and photogrammetry. If we look at the photogrammetry swath, same profile. If we look at this photogrammetry swath here, like I said, you're just collecting off of the top surface. You're getting that sun, reflects off the leaves, reflects off the top of the building, and comes back to the system. It's very similar to, if you take your project site, if you took a sheet and you draped your sheet over the top. If there's nothing on the ground and you have hard surfaces, photogrammetry is going to do excellent. But if you have anything, any sort of vegetation, any sort of objects where, you don't have a smooth, flat surface, you're only going to see that top surface. When you compare that to something like LiDAR, you get a profile that's going to look like this. And same exact profile, but with LiDAR, you can see how much more detail you have. Not only are you still getting the tops of the building, of the trees, but you're getting those in much more detail. You're also getting detail of the branches, of the trunk, and in most cases, most importantly, of the surface beneath that vegetation. From there, you can take you can classify out that vegetation and have that bare earth model that lives beneath that, in most cases, usually the data that you're looking for. taking a step back, if we look at Phoenix in general, what does Phoenix do? Phoenix is a systems integrator. Dan, you want to go? Yeah, perfect. Phoenix is a systems integrator. So we take these raw components, the laser itself, the IMU, take all these components, build these systems, and not only do the hardware side, but also the software side. On the hardware side, there's a few things that go into it. The most important thing is, of course, the laser itself, but the laser itself, without any of these other components, is kind of useless. You need a GPS, GNS antenna receiver that actually geolocates the system in space. You need the laser itself. You need the IMU, which is going to tell you the orientation of the laser on the drone, whether your pitch, roll, and your yaw. You need a way to store that data. You need a computer to get it to all talk to each other. And in most cases, you're also going to want a camera to colorize that data and collect imagery while you're collecting the LiDAR data as well. And how does that all play together? There's a variety of factors that affect your accuracy. As surveyors, as someone that's looking at collecting data and actually getting something valuable out of it, you need accurate data. The laser itself factors in, the GPS factors in, the calibration of the system factors in, the actual survey control that you're working with factors in, best practices on how to actually collect the data factors in, and finally your software. So you could have the best hardware in the world, but if you don't have the software to take that data and optimize it, you're still out of luck. You need all of these different factors to play together in order to have a successful operation. In practice, like I said, there's a number of factors that affect your data, but just having a good laser with a poor IMU is going to lead to a variety of factors. Having a really good IMU paired with a poor laser is also going to lead to a variety of factors. In a perfect world, we have high accuracy, high precision, and high point density. So, a dense point cloud. But your system selection is going to factor into what that looks like in the end. And like I said, that's why there's a range in system cost. There's a range in system performance that comes with that. So you've gone out, you've collected all the data. Now what? Like I said, the software is equally important as the hardware itself. There's a variety of steps that go into it. It can be a little bit overwhelming. To be honest, as you're first looking into, starting this program, if you have a traditional survey, survey collection methods, it's relatively straightforward. And now you've introduced this new technology. There's a lot that goes into it. And we understand that there's definitely, a learning curve. There's no denying that there is some learning and some training that has to go into, having a successful post-processing workflow. But we've also addressed that. One of the things that I wanted to touch on today is LiDAR mill. Perfect. And LiDAR mill is our post-processing solution that's semi-automated, allows you to take your captured data, upload it to servers at our headquarters in Austin, process that on our computers rather than on yours, and take that processed data, export data products, and then share that, whether you're exporting the data product and sharing that, internally directly, or even sharing, through the cloud link through our cloud viewer. Diving into that a little bit deeper, LiDAR mill is broken up into a few key steps. Number one, like I said, is uploading your data. So you've gone out, you've collected it, now what? Upload your data to our servers, and then we run that through what we call pipelines. So your first pipeline is NavLab. That's doing trajectory processing. So your drone's been flying through. How do we optimize that trajectory of the drone? So first step is optimizing the trajectory. From there, we run our spatial fuser pipeline, which actually is going to build out that point cloud. So you've got millions and millions and millions of points, but what do you do with those points? Fuse them together, create that larger point cloud, and then from there you can derive your different data deliverables from there. And And what do those deliverables look like? With LiDAR, your basic data product that comes out of it is a calibrated, colorized, classified point cloud in the LAS format, but we can do a variety of formats as well within LiDAR ML. We can do digital terrain models, we can do surface models, we can also do contours, we can decimate the point clouds to bring into CAD programs. We've made it really simple to take that raw data, process it through, and export into the format that's going to be most valuable to you in order to best extract value out of that. Collecting data is one thing. Being able to actually use it to either save money or make money, that's what's important to everyone.
All right. Thanks, Will. So I guess we're going to go ahead and stick to our time schedule here and open it up for some questions. If Alex wants to chime in, I don't know if we've got anything on the chats.
Hey, Dan, yeah, it looks like we have a couple questions that came through. All right, this one, not sure who's going to take this one, but what's the general rule of thumb for setting overlap when scanning with LiDAR?
Will, I'll let you take that one.
Yeah. So, if you're familiar with photogrammetry, you're usually at 75 or 80% overlap or higher. LiDAR, because it's an active sensor, each one of those points is in theory independent. So your overlap is much lower. Usually, 20 to 30% is a pretty good rule of thumb. Allows you to cover a little bit more area more effectively and still get a really quality data product out of that.
Great.
Perfect. Awesome. A couple more questions. What onboarding programs does Phoenix LiDAR offer when purchasing a Phoenix LiDAR product?
Yeah, good question. One of the big things with Phoenix and one of the things that really sets us apart is something that I experienced as a customer, honestly, and part of the reason why I was so enthused to come work for the team here. We focus very heavily, much like Multicopter does, focus very heavily on partnering with our customers. We don't want to just sell you a product and say, good luck, have fun, hope it goes well. With every system that we sell, we have training that goes along with it. We take you from maybe that initial conversation of just exploring LiDAR to helping choose the right tool for the job. And then once you get your system, going through training, we can do it. Typically it's in Austin at our headquarters, but we can also travel to you. Take you through a couple days of training, through flight planning, through best practices, on how you set up the mission, through executing that data. And then we also have a remote software training where our post-processing team sits down with you, takes you through, all right, collected the data, how does that post-processing workflow work? And what are the best practices there too to take that raw data and turn it into something valuable? Like I've said before, the key is the valuable data deliverable at the end. It's lots of fun to go out and fly drones around, but if it's not either making or saving the company money, it's not doing you any good. And our goal is to set you up for success with that.
Cool. All right. We have another question. Can the pilot set their own control or are they handcuffed by RTN?
Yeah,
Do you
I
need
can
a
take
little?
that one as well, Dan.
It's fine. You can take that, please do.
Yep. So setting control out on the site, there's a couple different ways, and I hope I'm understanding your question properly. With LiDAR, control is used more for accuracy confirmation rather than, necessarily specifically tying into the site. We want to make sure that our coordinate reference system is correct and that, your base station is set up properly. But when you set control out over the site, you can, within our software, you choose which one of those, which points want to be used either as control or as checkpoints. Again, because each point is inherently independent, it also inherently has its own accuracy. But if you can't verify that without checkpoints, how do you trust it? And that's where the control and the checkpoints come in. Hopefully that answered it.
Awesome. Me too. Yeah. One last question. How long does it typically take to process a 25 to 50 acre project?
Dan, you just did one
Yeah,
recently. You
I
want
mean,
to
I
talk
can
about?
take, yeah, I actually just did one the other day and I kind of referenced it at the start of the call, but, you know, assuming I usually like to do a little pre-planning before I arrive on a site. Making sure you're downloading everything on the controller that you need and your maps are upgraded, your airspace and all that fun stuff, right? So I think maybe like in-office pre-flight planning for me is about a 20-minute deal, right? And then this site we did in East Austin. Overall, the total time for that job was about 2 hours, but we were not rushing around. We did drive the entire site. We had to, set up the base station. Usually want to let that sit for a while. And then we put out some checkpoints, and we also almost got stuck in the mud twice. But the actual flight itself, the great thing about that is depending on the drone, you get that configured. The actual flight time was about 25 minutes. And sometimes I like to fly a job twice, especially because it is, with LiDAR, it's a pretty quick movement. But yeah, to answer the question, I'd say about 2 hours. But some people like to take more time, maybe to run their base station, and you can be very meticulous about the process if you want to. But hopefully that helps answer the question.
Dan, do you mind expanding on that a little bit? What about processing time? Processing a
Oh
25 or
yeah,
50 acre project?
yeah. How could I forget that? Well, in that particular flight, um, I would say it was probably, and the gentleman I was working with likes to do things on his own and kind of tweak things. So I would say processing for that was 2 hours. Um, but that I'm not sure, but if Will, like with that, because for LiDAR mill and your average job, what would you say to that, especially since you guys kind of take the burden off the user on some of
Yeah.
that?
Yeah, you're looking for, a small project like that. Honestly, you're going to spend more time kind of setting things up than you are actually letting the processing happen. Our servers are pretty beefy servers in Austin. So, running through a project like that, you're looking maybe 1 to 2 hours at most. But it's a pretty quick process to take that from, coming back in the office after being in the field and having a final deliverable out of it.
Yeah. And I guess, just as far as setting the drone up, depending on the machine, since most LiDAR payload drones are bigger drones, you're going to spend maybe 20 minutes just kind of getting the gear out, set up, everything kind of prepped and turned on, and verify all your settings. But yeah, I think if you wanted to maybe say 2 to 3 hours, but we were really trying to get it. When you try to take shortcuts, it's never good in anything with drones. So I recommend you take your time in the process.
Hey guys, we have one more question that just came through. What part does RTK play in LiDAR scanning?
Yeah. Um, I can take that here. So with LiDAR in particular, RTK is not as important in the field. All of our processing is done through PPK, so post-processed kinematics. And importantly, that simplifies operations in the field. You don't have to worry about dropping RTK for a half second and having it mess up your data. So you have your static base collecting, you have your GPS on the system itself collecting, and then it's not until you get back into the office that you do your PPK alignment. So RTK is not actually required for any of our LiDAR collection.
Perfect. I think that wraps it up, guys.
All right. Well, thanks everyone for attending today. And we usually do post these on our YouTube channel and various media outlets. But thank you so much, Will, for helping us out and joining us. We really enjoy working with you guys. Thanks for everybody that showed up. And you have our emails and all that stuff. Feel free to reach out. If you want to post anything in the chat, Alex will relay that to us. And we hope to see you on the next webinar. Thanks so much.
Thank you, Dan. Thank you, everyone.
Take care.